So our opening lesson, we're looking at the normal distribution curve, and this is something that we've seen before, so it won't be too unfamiliar. But I just want to start off with an example here, and that is to consider this experiment here, rolling two dice and then adding the score on each dice together. This is something that's very familiar to what we've done before. So one of the questions I want to ask you is, what is the maximum score? So when we add the two dice together, what would the maximum score be? Well, of course we know the answer is going to be 12, isn't it? As you can see by the diagram, the 6 plus 6 gives the maximum score of 12. What would the minimum score when you added two dice together be? Of course, the minimum score we know is going to be 2 with the 1 plus the 1. Let's see from the diagram, 1 and 1 is snake eyes for those people that frequent the casinos, which is probably not many of you anyway. Alright, so we know that minimum score is 2 with a 1 and a 1, and maximum score is 12 with a 6 and a 6. In between that, we've got all sorts of numbers. So you can get a 3 with a 1 and a 2 and a 1. You get a 4 with a 2 and a 2, a 3 and a 1, a 1 and a 3. And all that brings us, if we get that data together, to this thing called a frequency chart. And if we put this frequency chart together, we get exactly this. Down the bottom here, you can see the numbers. 2 is the sum of 2, sum of 3, etc., all the way up to sum of 12. We know the sum of 2 can only happen one way. That's a 1 and a 1. We know that 3 could be a 1 and a 2, or a 2 and a 1, and 4 is 1 and a 3, 2 and a 2, or a 3 and a 1, etc., and that's why we have 3 as the number of ways it can happen. And what we get is this big curve that goes up. Obviously the most popular number is 7. If you think of 7, 7 is 6, 1, 3, 4, 5, 2, and then the other way around, 2, 5, 4, 3, and 6, 1. There's 6 ways of making a 7 with two dice. Now the question is, if you were to put money on this, roll two dice, which number do you think you'd put money on? Well, of course, probably the answer would be going to be 7, because it happens the most number of times. And 7 obviously can happen 6 times. So the probability of 7 happening is going to be 6, the number of ways it can happen. How many ways can anything happen with two dice? Of course, it's 36, isn't it? And we've done this before. So the probability of rolling a 7 in terms of two dice is going to be 1 over 6. So one of the things we can do with this graph is take a look at the midpoints of every box on its top. And these are the little red dots that are going in here. These are the midpoints of every dot. And we end up with this curve that goes up. It's not going to be a straight at the top, it's going to curve down. And that is what we call a normal curve. And the normal curve means it is split down the middle at its maximum, so that 50% of the area is here and 50% of the area is here. And that's the characteristic of a normal distribution curve. Things we can do is look at the sampling. So if we were to roll the dice 100 times, would the graph look exactly like this? And that's what we're going to look at now. So if the dice was rolled 100 times, and this is what we've got in this top graph here, you can see 100 times there. And you can see from this graph that we've got this value here, the sum of 4 down here, sum of 5 there. Sum of 6 is obviously the one that's at the top. That happened 20 times out of 100, so 1/5 of the time it happened there. But we don't get this curve. We don't get the same curve we've got that we had with the normal curve. That's with 100 rolls. When we go to 1,000 rolls, it starts to look a little bit more like the curve, you see. You take these maximum values, there's a slight kink on the left-hand side, but compared to the 100 rolls, 1,000 rolls, it's much more different, and it's much more like this purple curve here, which is what we're looking for here, this normal, symmetrical curve. So the 1,000 rolls doesn't quite get there. But look when we went to 10,000 rolls. This one here down the bottom. So we've done 100, 100's on the left there, 1,000's on the right, getting closer. When we go to 100,000 rolls, all of a sudden the symmetry starts coming into this curve in terms of the distribution. So, and this is what we'll look at later in some of the lessons we do. When you take a small sample, it would try to reflect it in the big sample, but it may not reflect it totally. And that's what you can see from these. When you roll two dice 100 times, the sample isn't the way you'd normally think it's going to come out. When you increase it to 1,000, it gets better. But over a long period of time, with a lot of repetitions of the rolling these two dice, 100,000 times, all of a sudden we get this graph looking the way it should do, which is the way we predicted it to. And that, my friends, is statistics. And we've looked at this before. So this is the normal curve, and the characteristics of a normal curve is the mean comes right down the middle. There's symmetry both sides of the mean. And if you read this question, it's a pizza delivery, which we're all very familiar with. 30 minutes is the delivery time they look at, and it's got a standard deviation of 5. So the standard deviation this way would mean a 35-minute delivery. That's 30 plus the 5. And one standard deviation this way would be 30 minus 5, i.e. 25 minutes. So we've got this standard normal curve. Now what we said before is that the area to the right here is going to be 50%, and the area to the left is 50%. And we know that for a normal distribution curve, the mean, median, and mode are all the same. They're all equal because it's such a symmetrical figure. So we're going to advance this now. We're going to look at the z-scores. And we've done this on the last test, so it should be fairly simple. We're going to extend it a bit with this lesson here. So question 1 says, let's call that question 1, thank you. Find the z-score for a normal distribution with a mean of 16, a standard deviation of 4.2, and a data point of 20.2. So we know that z-score equals the data value minus the mean, all divided by the standard deviation. So we know our data point is 20.2. We know the mean is 16. So there's the data point, there's the mean, and we know we're going to divide that by 4.2. Well, it's just quite an easy one to do actually. 20.2 minus 16 is 4.2, and divide that by 4.2, and we get the answer 1. So the z-score for number 1 is 1. It won't get easier like that every time. Question 2, find the z-score for a normal distribution with a mean of 20.3, standard deviation 3.6, and a data point of 18. So we know that z equals, write down the formula each time, x minus the mean over the standard deviation. So our data point is 18 over here. We know the mean is 20.3 there. And we know that the standard deviation is 3.6. So 18 minus 20.3 is negative 2.3. Get your calculator out to check that if you want. I'm the mathematical genius, so I know it equals that. Then we divide by 3.6. Unfortunately, I don't do that on my head, so I'll have to get a calculator out. And the answer is 0.64. It's actually 3 decimal places, but it's 0.6388. I'll put them in all for now, but we only need 2 decimal places for z-score, so 0.64 is the answer. So these 2 questions are quite interesting. Again, this is questions 3 and 4. Find the data point now for a normal distribution with a mean of 13, standard deviation of 3.6, and a z-score of 1.121. So we're actually going to do this a little differently here. Same formula. So we're given the z-score of 1.21. And we're looking for the data point. So x is the data point here. So we're going to leave it as x. We know the mean is 13. And we know that the standard deviation is 3.6. So we have to unravel this to give us x. So we're going to multiply that times that. And 1.21 times 3.6 will equal x minus 13. So let's have a look, see what we got here. So we get 4.356. Let's keep all the decimal places in right now. X minus 13. We add 13, and we know that x equals 17.356. We'll leave that as 3 decimal places, 17.356. And question 4 here, we do the same thing. Write down the formula because we know we're on a roll right now in terms of getting the formula right. So Let's read the question. If the z-score is negative 1.32 for a normal distribution with a standard deviation of 2.1, it says find the mean now. So we know that negative 1.32 is our z-score. We know the data point is 18. We don't know the mean, but we do know that the standard deviation is 2.1. So we're going to cross multiply again, multiply this times that. So we get negative 2.772. Don't know why I've gone to black ink here, but anyway, not to worry. 18 minus the mean. That's quite interesting here. In this situation, these two, let's take the 18 over, so we get negative 2.772 minus 18 equals negative the mean. And we can actually negative 20.772 equals the mean, negative the mean. So the mean equals positive 20.772. There we go. That's the lesson done. You can do some questions on this now. That's the next resource.